Practical SQL Server 2012 Administration and Programming. Select statement, inner join, self join, outer join, and cross join. Let's start with inner join. In inner join, we connect the primary key to a foreign key of a different table. This way we can pull data from two different tables. Since the relational database has data distributed in many tables, this is the main way of bringing data together into usable format. So let's see what happens if we execute it. We have the rows from the employee table and persons table joined, and we are showing all the columns. The join key is business entity ID in both tables. And it appears that this is the person table, and followed by the employee table. Let's continue. We have a table alias E for the employee table and P for the person table, and we only select all the columns from table E, which is the employee table. So we have 290 rows in the employee table, and these are all the columns. This time we are selecting all the columns from the person table. We can do a count as how many rows are satisfying the inner join condition. And that's 290, the number of employees in Adventure Work Cycles. Now the person.persons table has almost 20,000 rows, but because of the inner join, we are only selecting 290. Who are the other people in the person.person table? Well, there are dealers, customers, contact persons, and if we eliminate the top 1000, we see 19,972 rows in the person.person table. In the following query, we are selecting specific columns. Now we are getting to real readable queries. Now we see the query is quite readable. We are not dumping all the columns across the board. We made the following query even more user-friendly by concatenating the first name space and the last name, so we can easily read the full name of a person. Let's continue. Let's do a less than join, and this is it when the sales order detail unit price is less than the product table list price. So we are joining on, this is a foreign key and this is a primary key in the product table, and this is the result of a query. performance consideration, foreign key should be indexed. For fast queries, the foreign key, in this case, in the sales order detail, should be indexed. Now, the primary key is always indexed. It has a unique index on it. So, let's look at the chart around production.product. So, new diagram. And we are going to select production.product table, product, production, and pull in all the related tables. Rearrange. Still pulling it in. Rearrange. So here it is. This is the product table, and we see all the tables which have a primary key foreign key relationship defined to the product table. So for example, if we look in the purchase order detail table, we see product ID defined as a foreign key to product ID of the primary key in the product table. Why we have to do this is to pull data together from all the related tables. So for example, we may need only product name from here to make the data more meaningful when we are looking at purchase order detail, because instead of product ID in a report, the user, or actually in today's terms we are calling the business intelligence consumer, wants to see the product name itself, not a product ID. A product ID is a meaningless number in this instance. So when we are joining tables, we are querying information in all the related tables. We may not be using all the information, only a subset of information. Let's continue with another inner join. In this instance, we are interested in a particular product ID, and there is no row satisfying the join condition, which is unit price greater than equal or list price for a particular product ID. And the following query returns 3 rows, all product ID 717, which is a road frame. And it was sold at a selling price which is higher than half of the list price. Of course, the higher the selling price is better for AdventureWorks cycles. Not equal join. In this instance, we have a product subcategory ID selected and the list price. So list price in P1 is less than 15, and the same in P2. P1 and P1 are aliases in this case, pointing to the same table, so this is a self-join. Now, to make the report more meaningful, we are joining in the product subcategory table 2, where we are going to get the names for the subcategories. And now immediately the report looks better. This is a self-join where we are joining purchasing product vendor with purchasing product vendor, and obviously we are looking for some relationship within the data in that table, and this is the result of a query. In this instance, we have a more sophisticated version of a self-join. And here it is. So these are the vendors for LL Crankcam, Vision Cycle, and Prosware. And for ML Crankcam, the same. For HL, we have West Junction. Actually, we have 3 vendors: West Junction, Vision, and Prosware. So we can locate for each product as who are the vendors by doing a self-join. Now, this information is not explicitly in the table. That's why we have to construct a sophisticated query, not too complex at this point, but fairly well structured query, to get this relationship listed in nice report format. Let's run the following query. In this, again, it's a self-join. We can see it. And we are selecting the last name neighbors, and this is easy to recognize that these are the Smiths. Since we are joining on the first 5 characters of the last name, we see that Steele is a last name neighbor of Steele, which is spelled with an E at the end. When we want to return non-matching rows from one of the tables in the join, we are talking about outer join. Left outer join is totally and completely equivalent to right outer join. Left outer join mostly used by developers who write left to right, and right outer join used by developers who write right to left. So let's check out the first example. In this example, the left table is product. That means we want to list everything from the product, even if there is no match, in sales order detail table. So let's just do that. And here is the result. But how can we explain it? Adjustable raise is not in the sales order detail table. Well, one reason it may be that it's a part. It's a bike part which is not being sold to the customers, so that's why it's not present in the sales order detail table. Meanwhile, all-purpose bike stand is being sold as a end-user item. Let's check the next left join. In this case, we use the isNull function to make this column filled with numbers completely instead of null. So we put -1, and we know that -1 indicates that there is no match. Nothing purchased from these vendors. We are looking for where vendor ID is null. So this is the list of the vendors. There are 18 rows. This is the right outer join. So we are looking for all the rows in the salesperson table. We flipped it around from left outer join. We can also say left join and right join. And here it is. Business entity ID 274 does not have a territory. And instead of a business entity ID, we listed the name to make the report more meaningful. In the following query, we are filtering on sales year to date less than 20 million. And this is the result. Full outer join. In full outer join, we want the non-matching rows from both tables. We can say full join as well. So we have non-matching items in the product name. In the following query, we do full outer join between the employee table and the person.person table. And this table has only 290 rows and the person.person over 19,000. And here is the result. So for example, if we slide across, we can see that business entity ID 293 has no correspondence in the employee table. Let's execute the following query. In this case, we have a good match, so we don't see nulls in the left or the right column. Cross-join is also called Cartesian products. This lists all the combination from one table with the other table. So for example, we got 4640 rows from this quite simple looking query, which is actually 16 departments times 290 employees, and that's equal to 4640. In some instances, the cross-join is useful in special algorithms, mainly mathematical oriented calculations. We don't usually use cross-join in normal business processing. Here is a mathematical usage for cross-join. We are generating a multiplication table and we get 100 rows. 10 times 10 is the last one in the multiplication table. Recapping, joins are used to connect tables and extract data, related data from the connected tables. We have different kind of joins, but the most commonly used is the inner join and left join for at least that part of the world where writing is from left to right, and in the other part of the world that the writing is right to left, right join is used. Left join is completely equivalent to right join. When we have self join, joining the same table to extract some interesting information which is not apparent in the table, and full join. Full join is not used very frequently either, and same for cross join. This is the end of the unit.